Namaste everyone. So today we are going to learn the very interesting topic, that is the process of formation of urine. So this process of formation of urine involves 4 steps. So the first step is that takes place here in the Malpighian body, that we call as a glomerular filtration. Okay, so that takes place in the Malpighian body, glomerular filtration, otherwise we can say ultrafiltration. So the second step is that takes place in PCT, proximal convoluted tubule, that we call as a tubular reabsorption. Tubular reabsorption is the second step in the formation of urine. And the third step is here this tubular secretion. Here tubular reabsorption in the PCT. In the DCT, tubular secretion takes place, and finally here in the collecting ducts, one step, very important step, that is the formation of concentration of urine. Concentrated urine, formation of concentrated urine or hypotonic urine. So let us see one by one what happens. What is the first step? That is glomerular filtration, that takes place here. As a result of difference in the lumen of the afferent and efferent arteriole, here pressure creates on the blood. Due to that pressure, so what happens, this blood capillaries possess small holes on their walls. Due to that pressure, through that holes blood get filtered, okay, except blood cells and proteins, remaining all water soluble substances, all the water soluble substances get filtered here in the Bowman's capsule. Okay, so then that we call, that filtrate we call as a primary urine. So this primary urine is like a blood, but so that means in the concentration it is like a blood, but this primary urine lack proteins and blood cells, remaining all same in the concentration. So then while that primary urine passing through this proximal convoluted tubule, so the reabsorption of water as well as useful substances takes place. Why? Because here this primary urine per day in our body, the primary urine takes place about 170 to 180 liters of primary urine will form. That means every minute our kidneys filters about 1.2 to 1.5 liters of blood. As a result of that, about 120 ml of primary urine will form per minute. Okay, so like that, more amount of primary urine will form. If we lose all that, even that leads to death. That's why here reabsorption takes place. That is the second step. So here about 75% of water reabsorption takes place in the proximal convoluted tubule. So that enters into this peritubular network. 75% of the water is reabsorbed into the peritubular network, along with some useful products like vitamin C and glucose as well as amino acids. All these reabsorbed into the peritubular network here. So then the remaining urine enters into the loop of Henle. So in the loop of Henle also, the reabsorption of water, mainly here this is a descending limb and it is ascending limb. In the descending limb, so the reabsorption of water takes place, and in the ascending limb the reabsorption of sodium chloride takes place. Okay, so like here in the loop of Henle as well as in the proximal convoluted tubule, reabsorption of useful substances and water takes place. Here in the loop of Henle, about 10% of water is reabsorbed into the surrounding tissues, and here also sodium chloride also reabsorbed into the surrounding tissues, interstitial cells. Okay, so the remaining urine, that means primary urine, enters into the distal convoluted tubule. This is distal convoluted tubule. So in the distal convoluted tubule, based on the concentration of wastages and materials and what everything, here what happened, from the efferent arteriole, that means it formed peritubular network. From the peritubular network, what happens, so waste materials enters into this distal convoluted tubule. That process we call as a tubular secretion. From the peritubular network, the wastages like urea, creatinine and some salts, some ions, hydrogen, chloride ions like that, they enter into the distal convoluted tubule. Okay, so along with that, finally it enters into the collecting ducts. So in the collecting ducts, what happens, based on the concentration of fluids in the body, so here one hormone releases, that is called ADH, antidiuretic hormone. So this antidiuretic hormone releases when the water content is less in the body fluids. So when the water content is less in the body fluids, so this releases, and this initiates the reabsorption of water from the collecting duct, from the primary urine. Then after that we will get a concentrated urine. It is hypertonic urine. So when compared to blood, it is a hypertonic. Here it is hypotonic. It is a isotonic. But when it enters into the collecting ducts, it get concentrated. So by the antidiuretic hormone. Okay. So like this, here the formation of urine takes place. So here in the collecting ducts, the urine get concentrated. So this happens as a result of ADH. This otherwise we can say as a vasopressin or ADH. So in some people this ADH won't releases, or if it releases less, what happens, they excrete highly diluted urine. In some people, so due to lack of this ADH, they release more diluted urine. That condition we call as diabetes insipidus. Diabetes insipidus. So this diabetes insipidus occurs due to lack of ADH. So this ADH helps in reabsorption of water from the collecting ducts. Okay, so the urine which formed here in the collecting ducts, this enters into the renal pyramids, and then from the renal pyramids it enters into the calyces, from the calyces renal pelvis, from the renal pelvis it enters into the ureters. You know, ureters are long tube like structures. So that ureters, in that the walls of the ureters, so they perform some wavy motions. Okay, so that we call as a peristaltic movements. Due to peristaltic movements in the walls of the ureters, the urine enters into the urinary bladder. So the urinary bladder is a pear-shaped muscular sac-like structure. Okay, it opens out through a tube called what do we call that? Urethra. Okay. The maximum capacity of urinary bladder, storage capacity of urinary bladder is about 600 to 700 ml. But when 300 to 400 ml of urine enters into the urinary bladder, so the walls of the urinary bladder swell and stretch, and the stretch muscles which are present in them, so they activate and send messages to the brain or central nervous system. Then we will get an urge to urinate, so that urine come out through urethra from the urinary bladder. So but it is under the control of two sphincters which are present at the junction of the urinary bladder and urethra. So the upper muscles are not under our control and the lower muscles are under our control. So in adults this is under our control, but in infants, so they are not, that means it is not voluntary, it is involuntary. Both the muscles are involuntary in them, so that's why they make their beds wet during the night. Okay, so like this urine formation takes place in humans and they excrete. So this is the excretory system in humans and how they eliminate waste materials from our body. So here we have to understand one thing: the urinary system or excretory system not only helping us to eliminate the waste materials from our body, it also helping us to maintain the osmotic pressure, osmoregulation. It helping in osmoregulation. That means it is keeping balance body fluids in our body in the balance. Okay, so that is the importance of excretory system in us. Okay, thank you.